Okay, today I'm going to run a few tests on the fuel pump circuit on my Subaru Vortex. It's the Series 2 EA82 MPFI system, so it has a 4-plug ECU with the Hotwire AFM meter. Something I've recently discovered is that the fuel pump in the system is not what I'd call conventionally operated, but it operates via a control ground from the ECU. Now what I mean by that is it has a fuel pump relay which is supplied constant voltage from the battery and then is switched via the ignition switch, and also a signal from the ECU to close the coil of the relay, sending the power through to the fuel pump. But then the ECU controls the fuel pump via an ECU ground, which is better seen in the full diagram here. We see the fuel pump with the plus 12 volt circuit via the fuel pump relay, which is also wired to the cold air speed control valve. And we can see this shielded control ground, fuel pump control from the ECU, which is pin 55 on the ECU, which is this one here, pin 55, listed as fuel pump control on a white lead. That's at the ECU connector anyway. And then we have the fuel pump relay control, also from the ECU, which is in orange on all these diagrams. So what I've done is made up a little adapter lead here for the fuel pump. We have a male and female, and I've intercepted that with this lead that I've run up through where the fuel pump lead goes, factory loom, through a grommet in the floor under the seat. Plug that into my multimeter and see what actual voltage we're getting at the fuel pump, because I suspect sometimes it's quite a lot less than battery voltage. So this is going to be quite simple to fit, this adapter loom. You can see the fuel pump there. So I'm running a factory fuel pump still. So what I'm going to do is disconnect this, insert my little adapter lead, like so, and then I'm going to pull the excess cabling through that I've added, like so. Plug it into my multimeter. Okay, so let's see what we have. This is going to be a cool start. It's not going to be a dead cold start because I have driven the car today. But so let's see our voltage under priming when you first turn the key to ignition. Okay, so this is why I like analog meters, because you can see the needle move in a linear mode. But anyway, we saw 11.86 there when it primed, dropped off to 0. So I'm just going to start the car. You can see there that it isn't showing temp, so it is a cool start. I'll just let it run and see what we have fuel pump voltage at the pump. It's at an idle of 1700. We're seeing 2 notches on the temp gauge now. As I rev the car, you can see the voltage increase. Sorry about my shaky hands. Going to shut it off there. I think the best thing to do now will be to go for a drive and see how it acts on the road at different RPMs, different driving conditions. And you can see it drop straight off to nothing there. And again, if we prime it, we'll get that 11.7 spike and then back to nothing. Okay, so we're going to go for a little drive now and see how these voltages run. So you'll see it prime now. Now starting. Okay, 10.7. Just pulling into a auto store now, so we'll see how it idles. It's up to temperature now. So there we go, it's idling at 950 and we've got under 10 volts. So what I've done here is put the multimeter next to the vac boost gauge. And I'll just give you a demonstration of how the voltage works with throttle. So it kind of correlates with throttle, as in more throttle, more volts to the fuel pump. But you'll see when we accelerate, that's not what happens. So at the moment it's idling, we've got 9.78 volts. This is basically the highway, so going to be taking it up to 100 k's now. So that's just gentle throttle. But as I add more throttle and we put it into boost, the volts actually drop off. Now if I back the throttle off to cruising, we get 12.4, almost 12.5. If I get back on the throttle again, they drop. So that's cruising at 100. 12.3, 12.5. If I go off the throttle, the volts are going to drop probably back to 10. Back on the throttle to cruise, I've got 12.5. And then if I accelerate, low 12s. That's the opposite of what we want. I'm just going to pull up here and let the car idle, and I'll show you one of the strangest conditions I've discovered during this test. So the car's at idle now on vacuum, as you can see there on the manifold pressure gauge, and we're idling at 9.84 volts. Now I've just put the car into park and put the handbrake on, and I'm just going to sit here and watch it. 9.82 volts, and then all of a sudden 12.76 with no other apparent changes to any other parameters. So RPM's the same, manifold pressure's the same, engine load's the same. It doesn't correlate with thermofans or air conditioning or anything. There's a thermofan just kicked in now. You can see, you can hear a little extra load on the engine, and just a couple of points dropped off the voltage. So it's very strange why at idle the ECU would just all of a sudden give the pump a lot more voltage even than when it's on full boost at highway speeds. So it's very, I don't understand, but I feel something certainly needs to be done about this. It makes zero sense why they'd design a system like this. And then now all of a sudden it's 9.75 again. For, again, no apparent reason. So there's an awful amount of variation there just at idle. Okay, so after about 1,000 kilometers of testing and taking lots and lots of samples to create some run charts, this is what I've come up with the trends. So here's what it looks like under warm-up. And here's what they look like town cycle. Now what I've included in town is just light throttle, anywhere between 40 k's to 70 k's. This is what the voltages look like under highway cycle, so that's anything from 80 k's to 110 k's. And this is what the voltages look like at a hot idle. So as you can see there, these charts are plotted from 9 volts to 13.5, all of them, they're all the same. So we can see our trends, and they're just really up and down, really random. Anyway, so am I happy with the factory system? Well, no I'm not, so I'm going to do something about it. So let's do that, and then we'll revisit some run charts after and we'll check out the difference. Okay, so I've done the tests and you've seen the graphs, you've seen the variation in the ECU control of the fuel pump voltage through its control ground. I'm not satisfied with the way it operates, certainly how it drops voltage off under boost. So there's one last thing we need to check, which is that this fuel pump relay plus 12 volts from the ECU, that if the ECU controls that properly, and what I mean by properly is that it just turns on with the ignition to prime and then stops, and then it doesn't turn on again until the engine starts, because we don't want power to the fuel pump and the other systems that it's connected to through the relay all the time the ignition's turned on, for obvious reasons, from as inconsequential as just power usage, right up until if we have a rollover in the car, we don't want fuel pumping around. Okay, so I'm just going to try that now. We're going to do that by checking the voltage from this lead on the pump, which is the plus 12 volts out of the fuel pump relay, to ground. Okay. So we've unplugged the control ground, so we're not going to get a ground through that on the multimeter. This line here, which is still coming off our fuel pump adapter lead, is this yellow one here. Okay. Turn our multimeter on to 20 volts. We should have nothing. And I'm going to earth my ground probe or the multimeter and turn the key on, and hopefully we just see a prime voltage and then nothing. Okay. Good. I'll try it one more time. Key off to ignition, just to prime, and then nothing. Now I'll start the car and we should see plus 12 or 12.5 or whatever battery voltage is the whole time the engine's running. 13.48. So I'm going to turn the key off now and we should see nothing. Beautiful. Okay. So now that we've done that test and confirmed that the ECU controls the fuel pump relay plus 12 volts in the way that I'm going to call a normal car does, we're safe to bypass this ECU control ground. So we're going to cut this line. That's no longer going to feed the pump. Okay, so just picture that as a brake. And what we're going to do is this terminal on the fuel pump is going to come straight around to ground, directly to ground. Okay, so here it is on a smaller drawing, the same modification we're going to do. The pink lead again, that's our control ground from the ECU. We're going to cut that, and it now is going to be like this, directly to ground. And we're going to do that by means of this one here. This is one of our main grounds for the ECU. This is a direct ground lead. Okay, we're going to bring it into pin 56 on the ECU, which is this bad boy here. Which, by the way, is linked into all the other grounds. The reason I've chosen pin 56 on the ECU is it's right next to our original fuel pump control, pin 55. So I'll show you how I'm going to do that now. Okay, so I've got my ECU adapter unplugged. Obviously disconnect the battery before you disconnect it. So what we're going to do is, as explained before, bypass pin 55 of the ECU and then add it onto pin 56, which is a ground. So pin 55 is this white one right here. So we're going to remove that pin from the plug. So that's him out. It's our original fuel pump control out of the ECU connector. So we don't even have to insulate that anymore because it's not even there. So I'm going to connect that to its next door neighbour, this black one here, which is our ground. Okay. Okay, I'm just going to solder that guy now. Just let the flux do its job. Let the solder run through so we don't just have an on-top joint. Cook a little bit of solder into the other side, just so all of that solder doesn't end up running down the wire, but we still get a nice join here where it's joined or where it's spliced. Okay, there we go, I'm happy with that now. Got a nice join. Solder's flowed through the joint adequately. So there's our bypass. So there's pin 55. Now we've insulated it from the ECU, not from the loom, and it's tapped straight into pin 56, which is our ground. So I'm going to insulate that now with some tape, and that'll be our fuel pump hack. Basically complete. Okay, so there we go. So it's in that second row, it's a little bit hard to see, but there's our white fuel pump control lead. So we've just turned that into a fuel pump permanent ground lead now. We've tapped it into a permanent ground for the ECU. So we've 55 to 56, pin 55 on the ECU is now nothing. So just a matter of refitting the ECU adapter now, and seeing what we've got voltage wise at the pump. Okay, so our ECU adapter's plugged back in, and we've completed the fuel pump bypass. So now let's see what sort of voltages we get for priming. Ignition on. Probably saw a quick peak there of 11.6. A bit hard to tell. I'll just start it now. So this is a cool start. It's not a dead cold from overnight start. And we're seeing 13.05 volts. So already we're seeing more out of fast idle than we were seeing on the highway before. So I'm going to keep an eye on this now for a couple of days and see how constant it is. But so far, very happy. Okay, so I promised before and after graph results. So I've had the new wiring system in the car for a few weeks now, done about 1,000 kilometres again, and I've taken numerous samples of voltages of all the cars being run and driven and everything, just like before, under the same conditions. So here's what we came back with. There's our factory wiring, how it looked on the warm-up cycle. And here's our new chart with our new readings under our warm-up cycle. And you'll note that the new and the old chart both use the same voltage range, and you can see how much difference there is in those two. So that's warm up. Next we've got town, the factory wiring, and our new wiring. Once again, voltage range on the graph is the same. Now we have our highway charts, factory wiring, and our new wiring. Once again, voltage range on the graph is the same. And our last set of charts is a comparison between the hot idle voltages, factory compared to new. Once again, voltage range on the graphs is the same. So you can see that there's a staggering difference between original and our new way of operating the fuel pump. We're getting a lot more constant voltages, and they're all between the 12.5 to 13.5 range. So very, very close to battery voltage. And I really think that could be improved even further if we not only tap the fuel pump earth straight to that pin 56, but if we also put a body ground earth ring right near the fuel pump itself, that'll probably make those voltages even more constant. Anyway, so I know it's been a long-winded video, and thank you for watching. I hope you feel it was worth your time, and I certainly found it very interesting, and I'm very happy that I sort of stumbled across this, I'm going to say, problem, and was able to improve it. So yeah, thanks again. Bye.